Okay, for this next lesson, we're going to review some of the results of part 3 on polynomial values. The last section of that piece of work, we wanted to find a fast way to find the remainder when we do a division like this. Okay, we're going to do the long division and then think about the faster way to find a remainder. Let's do these divisions and find our remainder first. So we have x and we have x cubed, which means that the top value is x squared times x cubed, x squared times minus 2, minus 2x squared. Then we subtract. 2 minus negative 2 will be 4x squared. Bring down your minus x. This value must be 4x because 4x times x is 4x squared. 4x times 2 minus 8x. Then we subtract again. Minus 1 plus 8 will be 7x. And we bring down the 1, which means that this value must be 7. So 7 times x, 7x. 7 times minus 2, minus 14. And then when we subtract, we'll get 15. So that's your remainder. So let's write that as r. We'll do this one by division again. X into x cubed, x squared times x cubed, x squared times 1, x squared, and subtract. 2x squared minus x squared will be x squared minus x. And then this value must be 1, x. X times x squared, x times 1 will be x. Then we subtract. Minus 1, minus 2x. Bring down the 1. This must be minus 2. Minus 2 times x, minus 2x. Minus 2 times 1, minus 2. So we have 1 minus negative 2, which is 3. So the remainder for that question is 3. Let's move that up a little bit. Okay, now the remainder theorem is actually, you've done it already in the last section, but you didn't realize it. We could state that if Px, the polynomial, is divided by x minus a, the remainder, or the r, let's just call it r, would be equal to P A. Okay, let's keep that there because that was the last result of your last section that you did. In this question, we've got x minus 2. The first question is x minus 2, which is telling you that the a value is 2. So if we can find P2, find the remainder. So let's put 2 into that polynomial. 2 cubed plus 2 times 2 squared minus 2 plus 1. So simplify that. 2 cubed is 8. 2 squared is 4. 2 fours are 8. Minus 2 plus 1. 16 minus 2. 14 plus 1, which is 15. So if you divide by x minus 2, the remainder is 15. And that number is the same as this one here by division. Okay. And we could similarly do the second one, but notice in this case, it's x plus 1. So the a value will be -1. We could rewrite it x plus 1. It's the same as x minus -1, couldn't we? Because minus negative is plus. So that means that the a value is -1. Okay. So if you put -1 into here, you will get 3. Okay, you can try that yourself. So formally, your remainder theorem is written as if your polynomial is divided by x minus a, then the remainder is the value PA, R just representing remainder. This is the remainder theorem. As an example, what is the remainder when Px is divided by x minus 2? So the first thing we need is what is the a value from the remainder theorem. Notice it's in x minus 2. You can write that as x minus a. And so you can tell from this that a must be 2. So if we put 2 in, let's check that we get our value. So put in 2 and see if we get a remainder. So 2 cubed plus 2 squared plus 2 plus 1. This will be the remainder without division. 8 plus 4 plus 2 plus 1. 8, 9, 10, 11, 12, 13, 14, 15. Okay, so your remainder in that question is 15. I'm not going to bother dividing it, but you could divide that and get the same answer by division. Okay, now one modification of the remainder theorem is if you're dividing by the divisor in this form, ax minus b. Okay, so if you divide by ax minus b, you need to evaluate p b on a. So for example, if your polynomial is here, 2x minus 1, you would be evaluating p b on a, so 1 on 2, half. Now the quick way to remember how to do this is let 2x minus 1 equals 0. If you rearrange it to be 2x equals 1, x equals a half. That will give you the value that you need to substitute. Okay, so just let your divisor equal 0 and rearrange it, and that will be your a value here that you use in the question. So for that question, 2x minus 1, we need to evaluate p to the half. So we'll put half into your polynomial, and this will give us the remainder. So we put a half in, cube minus 3 times a half, plus 4. Okay, a half cubed is 1 on 8. You can use a calculator here if you're not comfortable with your fractions. 3 times a half is 2, plus 4. Now, if you don't have a calculator, quite easy to do. I would recommend make each of these base 8, denominator 8. So this is already 1 on 8. Now, if we multiply top and bottom by 4, we get 4 3s are 12, 4 2s are 8. Good, we have a common denominator. 4 must be 32 on 8, because 4 8s are 32. And you know why I did that? Because when we have a common denominator, then we can add the numerators. So it would be 1 minus 12 plus 32 divided by 8. So 1 minus 12 is minus 11 plus 32 on 8. What's 32 minus 11? 21 on 8. And you can write it as a mixed number if you want, but improper fraction is okay. So just bear that in mind when your when your divisors are in this form, ax minus b or ax plus b. And you're going to see one of those shortly. We're going to carry out some more questions using the remainder theorem. We want to find the remainder after we divide this polynomial by these divisors here. So in part A, we've got x minus 3 as the divisor, which is telling us that the a value will be 3. This is the number you put into your polynomial. So P3, we evaluate that. So then we're going to get 3 cubed minus 7 times 3 squared minus 2 times 3 plus 4. So that will give us 27. 3 3s are 9. 7 9s are minus 63. Minus 6 plus 4. And if you calculate that, you'll get your answer minus 38 here. Okay, so when we divide our polynomial by x minus 3, the remainder will be minus 38. And for the second one, we've got x plus 2. If you rewrite that as x minus negative 2, x minus a, we can see now that a is negative 2. So take that number and put to your polynomial. So p minus 2 was minus 2 cubed minus 7 times minus 2 squared minus 2 times minus 2 plus 4. So we get minus 8. Minus 2 squared is 4. 4 sevens are negative 28. Minus 2 times minus 2 is plus 4, plus 4. So negative 8 will cancel the 4 plus 4, and your remainder will be minus 28. Okay, that's another one. Example 4. This is using the remainder theorem to solve a problem. The answer will be 3. Let's see if we can get 3. So the remainder when we divide this polynomial by x minus 2 is 20. So the remainder here is 20. Our a value, x minus a is 2. So that's telling us if you put 2 into your polynomial, you'll get the remainder, and we know the remainder is 20, that's given. We want to find the value of k. Okay, so we'll take our 2 and substitute to x. So you'll get 2 cubed plus k times 2 squared plus 2 minus 2. 2 cubed is 8. 2 squared is 4, 4k. 2 minus 2 is 0. But this expression here is equal to 20. So we just write an equals 20 there, and we solve for k, this part here. So you have 4k equals 20 minus 8. 4k is equal to 12. The k then must be equal to 3. You'll have questions in your sheet to do like this one. So we got the correct answer, 3. Here's another harder question. Now, notice here we have a polynomial, but in this case we have 2 variables, 2 constants that we want to find, a and b. These are your constants, not variables. And you're given 2 bits of information. When you divide by x minus 2, the remainder is 1. when you divide by x plus 1, the remainder is 28. So that's telling me we need to make two equations. So the first one here, the a value is 2, x minus a will equal 2. And it's telling us the remainder is 1. So that means that if you put 2 in your polynomial, you'll get 1 for the answer. For the second one, x plus 1. So x plus 1 is the same as x minus negative 1. So the a value here is negative 1. So if we put that value into your polynomial, we will get 28 for the answer. So you can see we're going to end up with two equations now. Okay, so for the first one, our equation, okay, we want to put 2 in, so 2 cubed minus 2 times 2 squared plus a times 2, or 2a, we'll change that later, plus b. And that will equal 1. Let's simplify that. 8, 2 2s are 4, 2 4s are 8, minus 8 plus 2a plus b equals 1. So 8 minus 8 is gone. So your first equation is 2a plus b equals 1, first equation. So let's do the same on this side. We'll put minus 1 into our equation. Minus 1 cubed minus 2 times minus 1 squared plus a times minus 1 plus b equals 28. So minus 1 cubed is minus 1. Minus 1 squared is 1. 1 times minus 2 is minus 2. Minus a plus b equals 28. So this would be minus 3. You'll get 31 on that side. So minus a plus b is 28, 31. Equation 2. Okay, so we've got two equations and they look like simultaneous equations, which you learn in grade 9. Let's write them down. 2a plus b equals 1 minus a plus b equals 31, equation 2. So if we do it this way, we can see we've got b and b. So I'm thinking maybe we can subtract these. So 2a minus negative a would be 3a. 1 minus, or b minus b is 0, which is good. 1 minus 31 is going to be minus 30. So from that equation, a must be minus 10. Right? And when you want to find b, we just put back to one of the equations. So 2a, and a here is minus 10, plus b, we're using this one here, equals 1. So 2 times minus 10, minus 20, plus b equals 1. The b will be equal to 1 plus 20 will be 21. And that's the answer we get here. A is minus 10, B is 21. Okay, so that's a case of simultaneous equations. When you have two variables like this, two constants, A and B, you must be given two bits of information when you solve for two constants. Okay, if you only have one bit of information, you can't find your values. Okay, so these are your exercises here. I think there's enough in the examples for you to be able to do these. So I'll wait for your homework and hopefully it's well done. Okay, see you later.